lead compensator design using root locus. Okay, today we are going to discuss how to design the lead compensator using root locus. And the first step is to draw the root locus of the uncompensated system. Okay, draw the root locus of uncompensated system. What's the purpose of doing this and drawing the locus of uncompensated system? By drawing the root locus of uncompensated system, we are finding the dominant pole SD. Okay, the dominant pole SD is equal to minus theta omega n plus or minus j omega n into root 1 minus theta square. Our aim is to find the dominant pole SD. And the equation for finding SD is SD equal to minus theta omega n plus or minus j omega n into root 1 minus theta square. If we know both the theta and omega n, theta is the damping ratio and omega n is the natural frequency. If we know both the values of theta and omega n, then there is no need to draw the root locus. We can directly find SD by using this equation. If theta and omega n are known, there is no need to draw the root locus for finding SD. SD can be directly found out by using this equation. If we know only the value of theta, okay, if we know only the value of damping ratio theta, we can find the dominant pole SD by using the equation. We know that cos theta is equal to theta. Okay, so theta is equal to cos inverse theta. At that time, we draw the root locus of the system and draw the angle theta, which makes with negative real axis. Okay, theta is the angle which makes this negative real axis, and this angle line meet the root locus, touches the root locus at a point, and that point is dominant pole SD. Okay, if only theta is not, we need to draw the root locus and find SD by using this equation. Otherwise, if both theta and omega n are not, we can find SD without doing this root locus. Okay, SD is equal to minus theta omega n plus or minus j omega n into root 1 minus theta square. We got the value of SD. For example, SD is equal to minus 0.5 plus or minus j 3.5. Okay, so at the root locus, we mark the point dominant pole SD by using the values of theta and omega n. That is the first step. First step, draw the root locus of the uncompensated system and find the dominant pole SD. We need to draw root locus only when damping ratio theta. If both theta and omega n are known, there is no need to draw the root locus. Just mark the point dominant pole SD. Okay, that is the first step. First step is drawing of the root locus and the finding of dominant pole SD. Next, second step. Second step is to mark the poles and zeros. Okay, mark the poles and zeros. Okay, we have an uncompensated system. Draw the poles and zeros of that uncompensated system. For example, let the uncompensated system G of S equal to K into S plus 2 divided by S into S plus 8. Okay, so the poles are 0 and minus 8 and the 0 is minus 2. So mark the poles and 0. That is 0, let it be minus 8 and the 0, that is minus 2. That are the poles and zeros. 0, minus 8 are the poles and minus 2 is the 0. Second step, mark the poles and zeros. Next, third step. Third step is we need to find the lead angle phi, and the equation for finding lead angle phi is equal to sum of angle contributed by the poles to SD minus sum of angles contributed by zeros to SD plus or minus n into 180. That is the equation. The lead angle can be found out by using the equation sum of angle contributed by poles to SD minus sum of angle contributed by zeros to SD into plus or minus n into 180. Normally we are taking n equal to 1 and the simple plus or minus we are taking this minus. For minimizing the lead angle we are taking minus value for minus and n equal to 1. Okay, how to find? We have 0, minus 2 and minus. 0 and minus 8 are the poles and minus 2 is the 0. Okay, so we need to find sum of angle contributed by poles to SD. So mat find sum of from poles to SD and from zeros to SD and measure the angle theta 1. E 0 contribute in the angle, that is theta 1. Next 0 contributed angle theta 2 and this angle be theta 3. So sum of angle contributed by poles to SD are theta 1 and theta 2, that is theta 1 plus theta 2 minus sum of angle contributed by zeros to SD. Here only 1 0, that angle is theta 3 into plus or minus n into 180. We are taking minus into 180. Okay, for example, this theta 1 plus theta 2 is equal to 180 degree and theta 3 is equal to 60 degree. Okay, we are taking theta theta 1 plus theta 2 minus theta 3 equal to, for example, let it be 212. Okay, theta 1 plus theta 2 minus theta 3 is equal to 212. So phi is equal to, what is phi? Phi is equal to theta 1 plus theta 2, that is 212 minus 180. Okay, the 212 minus 180 is 32 degree. Okay, that is the method. We need to find the sum of angles contributed by poles to SD minus sum of angle contributed by zeros to SD into plus or minus n into 180. Therefore, phi is equal to theta 1 plus theta 2 minus theta 3. Sum of angle contributed by poles minus sum of angle contributed by 0 minus 180. General equation is plus or minus n into 180. We are taking n as 1 and the symbol is taking as minus. Therefore, the equation is plus theta 1 plus theta 2 minus theta 3 minus 180. The answer, if theta 1 plus theta 2 minus theta 3 is 2112, we are taking just an example. Its value is 2112, then minus 180, that is equal to 32 degree. From this we got phi is equal to lead angle, phi is equal to 32 degree. What is the conclusion? From this we know that if phi is less than 60 degree, okay, the value of phi is less than 60 degree, we need to design only one lead compensator. Okay, if phi is greater than 60, we need to design two lead compensators in cascade. Okay, here phi is less than 60, only one lead compensator is needed. If phi is greater than 60, we need to design two lead compensators. That is the first. Next condition. Okay, next we need, our primary aim is to find the poles and zeros or the transfer function of the lead compensator. So we know that the transfer function of the lead compensator is equal to, what is the transfer function of lead compensator? Transfer function of the lead compensator, GC of s equals s plus 1 by t divided by s plus 1 by beta t. Okay, so here we got the value of phi. Okay, let us example phi is equal to 32 degree. Just for an example, we are taking phi is equal to 32 degree. So here we mark the poles and zeros, mark the point SD. Okay, next step, the fourth step is to, here we mark the poles and zeros. Okay, here we mark the poles and zeros and dominant pole SD. Let this point be P, dominant pole point be P. Okay, then draw a line. Next step, draw a line parallel to x-axis. Okay, next we are considering a line which is parallel to x-axis and let it be AP, that line be equal to AP, and also draw a line to this origin. Okay, this line here, there is also a line to the origin because we have a 0 at this point. So we have a line parallel to this dominant pole SD, and that line is AP. Next step is to draw the bisector of angle APO. Okay, first we have dominant pole SC, draw a line parallel to x-axis, then also mark a line from this SD to the origin. We have already a 0 pole at the origin, so we have all the line. So bisector of angle APO. What does it means bisector? Bisector means if this total angle is, let it be 120 degree. Okay, let it be 120 degree. Total angle endana 120 ആണെങ്കിൽ അതിന്റെ ഹാഫിൽ വരയ്ക്കുന്ന ലൈനെയാണ് എന്ത് പറയുന്നത് ബൈസെക്ടർ എന്ന് പറയുന്നത്. ഓക്കെ, അപ്പം നമ്മൾ എന്ത് ചെയ്യുക, ആംഗിൾ APO എന്ത് ചെയ്യുക, മെഷർ ചെയ്യുക. First measure the angle APO and draw the bisector. Bisector means എത്രയാണോ മെഷർ ചെയ്യുന്നത് അതിന്റെ ഹാഫിൽ വരയ്ക്കുന്ന ലൈനെയാണ് എന്ത് വിളിക്കുന്നത് ബൈസെക്ടർ. So bisector of angle APO. Okay, bisector of angle APO. Next step, fourth step, draw the bisector of this angle APO. This bisector of angle APO is drawn by, first measure the complete angle and draw a line half of this angle. Total 120 degree angle 60 degree വരയ്ക്കുന്ന ലൈനെയാണ് എന്ത് പറയുന്നത് ബൈസെക്ടർ. ഓക്കെ, ഇപ്പോൾ ടോട്ടൽ ആണെങ്കിൽ 140 ഡിഗ്രി ആണെങ്കിൽ 70 ഡിഗ്രി വരയ്ക്കുന്ന ലൈനാണ് എന്ത് പറഞ്ഞാൽ ബൈസെക്ടർ. സോ ഫസ്റ്റ് ഡ്രോ ദി ബൈസെക്ടർ at this point, and we have already find phi. Let it be phi is equal to 32 degree. Okay, we consider phi is equal to 32 degree. From this angle mark phi by 2. Okay, if phi is equal to 32 degree, then what is phi by 2? Phi by 2 is equal to 16 degree. Mark the angle phi by 2 from this bisector. This bisector in the phi by 2 in the രണ്ട് സൈഡിലോട്ട് മാർക്ക് ചെയ്യുക. This is phi by 2 and this is phi by 2. Okay, നമുക്ക് എത്രയാണ് ടോട്ടൽ 32 ഡിഗ്രി ആണ്. അപ്പോൾ നമുക്ക് ടോട്ടൽ 32 ഡിഗ്രി കിട്ടണം. അപ്പോൾ എങ്ങനെ വരയ്ക്കണം, 5 by 2 എടുക്കുക. 5 by 2 is 16 ഡിഗ്രി. 60 ഈ ബൈസെക്ടറിൽ നിന്ന് 16 ഡിഗ്രി രണ്ട് സൈഡിലോട്ട് എന്ത് ചെയ്യുക, മാർക്ക് ചെയ്യുക. ഇവിടെ നിന്ന് ഇങ്ങോട്ടും എന്ത് ചെയ്യുക, 5 by 2 ഡിഗ്രി നിങ്ങൾ എന്ത് ചെയ്യുക, മാർക്ക് ചെയ്യുക. സോ ദിസ് ഇസ് 5 by 2. അപ്പോൾ വി ഹാവ് എ പോയിന്റ് അറ്റ് ഹിയർ ആൻഡ് വി ഹാവ് എ പോയിന്റ് അറ്റ് ഹിയർ അല്ലേ. നമുക്ക് രണ്ട് എന്ത് കിട്ടി, പോയിന്റ്സ് കിട്ടി. ക്ലിയർ ആണല്ലോ, ഈ ബൈസെക്ടർ വരച്ചപ്പോൾ നമുക്ക് കിട്ടുന്ന രണ്ട് പോയിന്റ്സ് കിട്ടി. ഈ പോയിന്റ്സിൽ നിന്നാണ് നമ്മൾ എന്ത് കണ്ടുപിടിക്കുന്നത്, വി ഹാവ് ടു ഫൈൻഡ് ദി പോൾസ് ആൻഡ് സീറോസ്. വി ഓൾറെഡി ഡിസ്കസ് ഇൻ ദ ലീഡ് കോമ്പൻസേറ്റർ ഡിസൈൻ. In the case of lead compensator, which one is placed nearer to the origin? 0 is placed nearer to the origin. Right? 0 is placed nearer to the origin. So we are taking this point as 0 and this point as pole. Okay. Therefore, the compensator transfer function of the lead compensator GC of S equals S plus 1 by T divided by S plus 1 by alpha T. This 1 by T is the pole. Okay, so that is S plus 0 divided by S plus PC. Okay, bisector വരച്ചിട്ട് നമുക്ക് എന്ത് കിട്ടും, ബൈസെക്ടറിൽ നിന്ന് എത്രയാണോ phi കിട്ടുന്നത് അതിന്റെ ഹാഫ് എടുത്തിട്ട് എന്ത് ചെയ്യും, രണ്ട് സൈഡിലോട്ട് വരയ്ക്കും. ആ വരയ്ക്കുന്ന ലൈൻസ് എവിടെ ജോയിൻ ചെയ്യും, ആംഗിൾ ലൈൻസ് എക്സ് ആക്സിൽ എന്ത് ചെയ്യും, ടച്ച് ചെയ്യുന്ന പോയിന്റ്സ്. അപ്പോൾ നമുക്ക് ഫോർ എക്സാമ്പിൾ ഇവിടെ ഇപ്പോൾ ഒരു -7, ഇവിടെ ഇത്ര -12 ആണെങ്കിൽ ഏതാണോ ഒറിജിനോട് അടുത്ത് വന്നിരിക്കുന്നത്, ലെറ്റ് ഇറ്റ് ബി ടേക്കൺ ആസ് 0 ആൻഡ് അതർ വൺ ഈസ് ടേക്കൺ ആസ് പോൾ. സോ ദിസ് ബിക്കം S plus 7 divided by S plus 12. Okay, that is the transfer function of the lead compensator. Okay, the fourth step we are finding the bisector angle and find the transfer function of the compensator. And the transfer function of the compensator is S plus ZC divided by S plus PC. That is S plus, let it be example, S plus 7 divided by S plus 12. That is the procedure for finding the transfer function of the lead compensator. Okay, next we need to find the transfer function of the compensated system. Okay, next we need to find the transfer function of the compensated system. The transfer function of the compensated system is equal to GC of open loop transfer function of the compensated system. Open loop transfer function of the compensated system, G naught of S equals G of S into GC of S. Okay. Transfer function of the compensated system is equal to G of S into GC of S. We have considered this G of S is equal to K into S plus 9 divided by, S plus 2 divided by S into S plus 8 into GC of S. GC of S is S plus 1 by T divided by S plus 1 by beta T. Okay. From this equation we can hear that we have not find the open loop gain K. Find out open loop gain K find out. Next step we need to find this open loop gain K. The open loop gain K is find out by using the equation K is equal to product of length of vectors from all poles to SD divided by product of length of vectors from all zeros to SD. Okay, product of length of vectors from all poles to SD divided by product of length of vectors from all zeros to SD. Let's consider here the poles are, this one is 0 is a pole, that is L1. We have another pole that is at minus 8, that is L2. And by designing the compensator, we got the next pole, that is pole offered by this compensator. We need to consider that pole also, that is that length is L3 divided by product of length of vectors from all zeros to SD. Where zeros are minus 2 and minus 2 and minus 7. That length be L4 and this length be L5. Okay. So the equation is K is equal to L1 into L2 into L3 divided by L4 into L5. Okay. So we need to consider the poles and zeros contributed by the compensator also. Okay. Find out in consider compensator provide the pole in the zero length poles in zeros consider. So K is equal to L1 into L2 into L3 divided by L4 into L5. So we got the finally we got the open loop transfer function of the compensated system. Okay, open loop transfer function of the compensated system is equal to G of S into GC of S, and this step we need to find the open loop gain K, where K is find out by using this equation, and K is equal to here L1 into L2 into L3 divided by L4 into L5. So we got the transfer function of the compensated system. Okay, GC of S equals transfer function of the compensated system, G naught of S equals G of S into GC of S. Last step we need to check whether the design satisfied or design is acceptable or not. For that, G naught of S equals G of S into GC of S. Some requirement is given in the question. Sometimes is velocity error constant. Okay, velocity error constant or steady state error may be given in the question. Check whether this compensated system satisfies this velocity error constant or the steady state error or something like that. Okay, so G naught of S equal to G of S into GC of S is the open loop transfer function of the compensated system. And finally, check whether the system is acceptable and it achieves the desired performance. Okay, that is the last step of the lead compensator design. Okay, if the lead compensator does not satisfy the requirement, we need to redesign the system by changing the positions of poles and zeros. We design the system in the design acceptable required performance achieve we need to change the positions of these poles and zeros. The poles in zeros in the location relocate we need to repeat the design. Design repeat. That is a procedure of lead compensator design using root lockers. Okay. For initially we need to find the dominant pole SD. Second step, mark the poles and zeros of the uncompensated system. Third step, find the lead angle phi. And the fourth step, find the poles and zeros by using that bisector. Find the poles and zeros. So from the poles and zeros we got the transfer function of the lead compensator. Next step, find the open loop transfer function of the compensated system, and the compensated system is equal to G of S into GC of S. And by doing that step, we need to find the K, open loop gain K. During the time of finding the open loop gain K, we need to find the poles and zeros length contributed by the lead compensator also. Okay, and last step, check the design is acceptable or not. Okay, that is a procedure for the designing of lead compensator using root locus.